Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You begin by confirming essential system readiness. Power, vacuum, and cooling must be stable before you touch the stage. Once done, secure the sample on a conductive stub using paint or tape and make sure it sits centered and clear of holder edges so the stage can move freely. Now choose a low starting accelerating voltage, usually between 1 and 5 kV, and a conservative beam current to prevent charging. This gives you a safe initial image to focus and align the detector. Next, you refine contrast and resolution by adjusting working distance, focus, and stigmation. Make small changes so you can see why the image shifts. Shorter working distance improves resolution but reduces depth of field. Then switch detector modes based on what you need. Secondary electrons reveal surface topology, backscattered electrons highlight compositional contrast. Once aligned, you can carefully raise voltage or beam current to resolve finer features, but make sure to watch for beam damage. Finally, capture high-quality images using suitable dwell times and line averaging to reduce noise. Save both raw files and annotated exports along with full metadata for reproducibility. Make sure you calibrate the scale bar using a stage calibration standard and record all key parameters: accelerating voltage, beam current, magnification, working distance, and detector used. If images quickly deteriorate or show streaking, check vacuum integrity. Clean the sample or chamber, reduce beam dose, or apply a thin conductive coating to mitigate charging as your first troubleshooting move.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.